In this video, we are going to work on an example for the third category, which is the when the parameter of interest is the variance or a standard deviation. So we want to do the hypothesis test. So you can see the question right now. So I would recommend that you would pause the video and look at this, read the question, and try to work on that for a few minutes, like 3-4 minutes by yourself. Then come back and then look at the approach that we are gonna work here, and compare it with your answer. So with the for this hypothesis test, is on the problem context is that we have the automatic filling machine that we would use to fill the bottle with the liquid detergent. So what are we going to do is that we are looking to see that if the variance of the fill volume exceeds some number, which is like 0.01. So in that case, an unacceptable proportion of bottles will be underfilled or overfilled. But so here is like that. We want to know that, we want to make sure that to see that if the variance is going to be greater, that it's going to exceed that number or not. So for this one, the first, when we want to do the hypothesis test, so the first step is that after we decided, we identified that we are in the third category, right? So we would say that, okay, so what's the parameter of interest? So the parameter of interest here it's sigma 2 or sigma. In this question, we are talking about the variance, so it's going to be sigma 2. Okay. So step number 2 is that it says state the null hypothesis. So for stating the null hypothesis, we would say, okay, so our sigma, right? Sigma 2, which is the variance, is equal to the 0.01. So it's equal to the 0.01. And then step number 3, which is to specify your alternative hypothesis, is that, so alternative hypothesis here is the things that we don't want it to happen, right? So it's like that because we said that if our variance is greater than 0.01, exceeds this number, something wrong is going to happen after that, which is like it's going to be overfilling or the like let's say overfilling or underfilling, something like that. So but there is something wrong with it. So H1 is like that. The alternative hypothesis is that our variance is greater than 0.01, and then we want to specify our alpha. So our alpha is 0.05, like 5%. Then we want to talk about the test statistics. So here for the test statistic, we said that for category number 3, we are going to work with the chi-square null. So the chi-square null, I'm going to just write down the equation of it here, n-1, and then S2 divided by the sigma 2, the sigma null 2. So that's going to be my test statistic. And then the next one, we are at step number 6, which is we want to see what's the rejection region. So as it's a one-sided, so the rejection region that we would have here is going to be, we would say, reject the null hypothesis if our chi-square is going to be like greater than some number. So is that we would say if our chi-square, this one, null, is going to be greater than the chi-square for this alpha. So it's like at 0.05 and n-1. So depending on what's going to be our n value here, so we're going to find out the degree of freedom for it. So I'm going to write down n-1 for now. So that's the rejection one. The next step is the computation. So we want to see that what's going to be our x null value. So 7 is the computation. And for computation, I need to look at my n. So n here is 20. Then we need to write down our s. So from the question, we will see that our s is 0.0153. right? And then our sigma, like S2, is this number, and then we have our sigma 2, which is equal to sigma 2 null, which is 0.01. So we have, from here, we can find out our chi square null, which is equal to, when we put these numbers, it's going to be equal to 29.07. And so we want to, and number 8 is the conclusion, right? So we want to compare this chi square null with this value, which is coming from the alpha. So this value, we need to go to the chi square table and find out the value of the chi square when we have, for the, so we go to the chi square distribution table, and then we look at it. It's very similar to the T1, but it's skewed, so it's a little different, right? But the way that you would read it is that on the first column, you would have your degree of freedom, and then you have your amount of the alpha here. So depending on that, if you're looking for the half of the alpha or alpha, you're going to look at this number and then this number, and you will read the value of it. So for here, we're looking for the 0.05, and n minus 1 is 19. So I'm going to look at it. So 0.05 and n equal to 19. So the value that I will find, you can see it as well, is 30.14. So this value here, so the chi square at 0.05 and 19 is 13.14. So now I can compare this with this value to see that if it's greater than this or it's less than it. So, and we can compare it. So you would say that this one, chi square null, which is equal to 29.07, it's less than my chi square at 0.05 and 19. So it's less than chi square at 0.05 and 19. So think about it for a moment. When it's like this, then we can conclude that we fail to reject the null hypothesis. So what we're going to do, I'm going to write down here, we fail to reject the null hypothesis. Or I can say that we can conclude that there is no strong evidence that the variance of field volume exceeds this number of the 0.01. So this is the exercise we worked on an example for the third category of the hypothesis test. It's good that if you work on that by yourself as well, and then compare your answer with this one.